A very good afternoon to all of you. I am very privileged to welcome Dr. Arthur Frank to our institute today. Now I would request Professor Rima to please introduce Dr. Frank.
Thank you, Archana. It's my great honor and privilege to introduce a stalwart and a leading authority in the field of environmental and occupational health. Dr. Arthur L. Frank, he's an MD and a PhD, is a professor of public health and medicine at the Department of Environmental and Occupational Health, Drexel University, Philadelphia, USA. He completed his medical school at Mount Sinai School of Medicine in New York. He has worked at the National Cancer Institute, NIH, and has set up departments in 3 medical schools in the US. He is also a part of Collegium Ramazzani. Now, what is Collegium Ramazzani? It's an organization which has about 182 renowned experts which help to bridge the gap between scientists, the scientific discoveries, and actually the social and the policy makers, the political groups, so that actual scientific discoveries can really impact public health in a positive way. He's also a member of the IIT Obama Singh Grant Committee. He has over 50 years working in the area of asbestos and has had a PhD topic where he worked on the effect of asbestos on health. But he also deals with the effect on occupational lung diseases by exposure to silica, how manganese-induced Parkinsonism in welders, benzene and its occupational and its hematological effects, and has also cared for these workers as a physician. In India, he has trained doctors for industrial safety on issues of occupational health at ESIC and for the Factory Regulatory Authority. He chairs many public health-related government committees in the US and has published in numerous high-impact journals which has had a positive impact on public health. And he's also on the editorial board and review panels.
Thank you so much, Professor Dada. Yeah, I'm never one for flowery introductions, and that was very kind. You heard that I was at Mount Sinai, and I was actually in the very first class when the school opened, and we had many events during that very first year of the school, including inauguration of the first dean of the medical school. And we had gotten to meet him early on as these 36 students, a very small number, and he got to know us. And at his inauguration, we had liked him, and I'd been chosen by my classmates to give him an award or a gift from our class, welcoming him to be dean of the new school. And this was our first year of medical school. And he was very touched. It was a surprise. It was not on the listed program, which was a major issue. But there were lots of other speakers. But he said something that night I've never forgotten as we presented him with the gift. He said, "It's not what you think of me at the beginning as you're starting medical school, it's what you think of me at the end when you finish. And so I can have all the flowery introductions, but I still have to earn your respect by hoping that I can share some things with you today about my career and my thoughts about the fields of occupational and environmental health. And what I'd like to do today is take you on 2 journeys with me. One journey is high up in the sky, the so-called 30,000-foot view. Some generic thoughts about what is important in terms of our environment in the 21st century. And we'll talk a little bit about that, and it particularly has relevance to India. Just to give you a sense, I've been coming here more than 36 times now over the last 22 years. I, for years, came twice and 3 times a year. This is my 2nd visit this year. I've been connected with MAMC or institution nearby, but know that I'm now speaking at the premier institution in medicine in all of India, and the respect that this institution has is not lost on me. So it's truly an honor to be here. The other trip that I want to take you on is a much more intimate one, a very narrow one, but it's what's given me 50+ years of my own research and work. And that's the world of asbestos, and we'll share with you some thoughts about that and why that's important. So, as academics, especially someone like myself at my stage of my career, we can think the big thoughts, but we develop the ability and the right, perhaps, to say those things by contributing and becoming well-known in perhaps one or another small area. So with your indulgence, I'm going to take you on some trips with me today. So I'm going to start with this. If I just left you with this one sentence and then sat down, an important point would be made. I certainly believe the existential threat to our planet right now is global warming. And that brings up all kinds of issues, some of which we'll touch on. But I will also share with you that I come out of the field of occupational medicine, which added the environment about 2 or 3 decades ago, because we recognized that hazards didn't stop at the workplace gates. They went out in the air, they entered the water supply, they came home on workers' clothes and contaminated their households. But in the areas of tobacco, asbestos, lead in gasoline, industry knew that there were hazards, but didn't want people to know. And we're dealing right now with the fossil fuel industry telling us, with about 2% of the world's scientists who they pay well, that global warming is not a problem. Unfortunately, we have a presidential candidate in America that calls the issue of global warming a hoax and something that isn't to be believed. The potential risk of not believing it and not doing something about it will put everyone on this little planet we all live on in grave danger. I'm not so much concerned about myself, but I have children, I have grandchildren, and they're the ones I worry about because there's going to be a major threat. And that is the 30,000-foot view that I wanted to talk about. But there is a history to how we've developed knowledge. As early as the 1950s, a fellow named Paracelsus, he was the first really toxicologist. He was a physician, but he also was an alchemist. Didn't successfully turn dross into gold, but he realized that materials could be hazardous. And so one of the things he said, a profound statement, some of the most profound things we know come in very simple statements. And what he said was, the dose makes the poison. And that has held up for 500 years. The classic dose-response relationship tells us the more you're exposed, the more likely you are to get disease, be it a bacteria or a virus or a fiber in the air or anything else. Shortly thereafter, in 1556, a metallurgist, a fellow named Agricola, he was also German, Paracelsus was, they took Latin names, of course, in those days, wrote a book called De Re Metallica, all about metals. And he spent most of the book talking about the mining of metals. He wrote about the smelting of metals, how to produce metals. He didn't want to change it into gold. He was dealing with what he saw. But he had a very interesting chapter in his book. And the chapter that he had was that there were health effects from this. And he wrote about the communities in which the miners lived, where some women would marry 6 and 7 times because their husbands would all die from working in the mines. And the question was, what were they dying from? Was it the dust? Was it tuberculosis, which was an issue and connected to dust exposures? Or was it something else? And it wasn't until 1870s that 2 pathologists, interestingly enough, in Germany, Hartung and Hesse, looked into this, and they reported that from those mining communities, they were able to locate records on literally hundreds of cases of lung cancer. This was before cigarette smoking. So what was the cause of that? Well, we figured that out a bit later. They didn't know what the cause was, they knew what the disease was. These were the same mines that Marie Curie got her 3 tons of pitch blende to make her 10 milligrams of radium. These were radioactively contaminated mines. And these men were dying of lung cancer that was radiation induced. So there's this development of knowledge and history. The father of our field of occupational medicine is a fellow named Ramazzini. The collegium is named after him. He was born in this little Italian town in northern Italy in 1633, became professor of medicine at Padua, and in 1700 wrote on the diseases of workers. And he added one question that was the first change in a 2,000-year history, at least of Western medicine, of approaching patients. And to paraphrase, he says, it is incumbent on the physician caring for the common man to ask of them what they do for a living. Now, for those of you that have had medical training, I suspect the amount of training you got in occupational history taking was either nil or close to it. And that as you practiced medicine, you didn't think on a regular basis to ask about exposures. That's not unique to India. We have the problem in America, we have the problem in all the countries that I visited. Doctors do not get trained to ask people about their exposures. And when you stop and think for just a minute, 60, 70% of any population have people at work. And 100% of populations live in an environment that's characterized by water and air and what grows in the soil. And yet, as physicians, we don't train our students who come after us, and as practicing physicians, with a few exceptions. This is what I do for a living, so I do it, but not many others do. Ask about what people do. And we end up making those connections of figuring out why those miners died, because we put the sense together that this was a radioactively contaminated mine giving rise to lung cancer. So first the field was called industrial medicine, then it was called occupational medicine, and probably about 30 years ago they added the word environmental medicine to it because of the reasons I said, that things leave workplaces. So we understand that hazardous materials enter our air, water, soil, and our homes. Nevertheless, in many parts of the world, including India, basic sanitation issues are still a problem. Access to clean water, air, sanitation issues. A few years ago, the United Nations had the Year of Water. But as we sit here today, there's still probably 2 billion people or more that on a daily basis do not have access to clean water in many parts of the world. And even when there is water that might be clean or could be cleaned, the world is starting to run out of water. And Chennai, was almost out of water a little while back. And it's happening in many parts of the world that there are inadequate water supplies. So water availability is going to become a more significant issue going forward, and is going to be a result in large part because of climate change. Glaciers are melting. So in a place like Peru, where they grow 400 different kinds of potatoes, the potato farmers depend on the glaciers melting and irrigating their fields every year. Those glaciers are going away. And when they go away, and there's not going to be as much snowfall in the future, what's going to happen to their food supply? We overuse aquifers, and in some parts of the world, ground is literally subsiding and shrinking and cracking buildings above because so much water is being taken out of the ground. And then in many parts of the world, rivers are starting to dry up. We are having big political fights in America over the western states using the Colorado River, for example. Colorado uses it, Arizona uses it, California uses it. Who gets to use what water? And so these are going to become major issues, and I suspect that over time, if we're not careful, we are going to end up with armed conflict in the world between countries about who's going to get to use water. That's what the future holds if we don't think about these issues. Clearly, if we don't have water, it's going to affect agriculture. We're going to have reduced crop yields. We're going to have weather events that are different than before. We've been seeing that. Just last week in the States, in the state of North Carolina, they had a once-in-a-thousand-year flood, which they'll probably have in the next 2 or 3 years again, because it's no longer once in a 500 years or once in 1,000 years. It's going to be every few years. Hurricanes are getting stronger because the waters that they grow on, the water is stronger, it picks up more water, makes them move faster, the winds are faster. Typhoons, same thing. So weather is going to affect climate, and this in turn will affect agriculture. We're going to see a shift of growing patterns. Things that couldn't grow at certain elevations or in certain climates, now you're going to start growing things in places that you couldn't grow them before because it's just warmer. But what that also means, in the places that did grow them, they're getting hot enough that deserts are growing. The Sahara Desert is getting bigger right now. So these are things we have to worry about. And then there's pests. When winters are cold enough, it kills off the pests that overwinter. They get into the bark of trees, they get into the soil, but when it got cold, it killed them off. But now they overwinter and they come out the following year. And so even the hazards from pests are going to increase in terms of affecting agriculture. Here we are in India. I certainly don't have to tell you, and I don't have to tell you in this city, about the issue of air pollution. The continuing use of fossil fuels worldwide will increase death and disease. We've only begun to appreciate that in the last, 15 or 20 years. And I look at countries, I've spent a fair amount of time in China over the years as well. I mean, you have the problem not only of fossil fuels, but the burning of the fields out in the western parts of India that blow over Delhi and move eastward across your country. So we need to find ways for those farmers to recycle the materials that they're trying to put back in the soil without actually having to burn them and causing problems here. But again, the field that I work in of occupational health is probably the most political field of all of medicine. You have the inherent tensions between employers and employees. But I never saw it that way. I always thought that employers wanted a healthy and stable workforce where people weren't getting hurt or dying off, so that they could have a productive workforce that knew how to produce things. And workers wanted to be able to come to work, make a good living, go home, be with their families, and not get killed for work, literally. We'll talk about that a bit later. And there's really no inherent difference in what people want. It's sort of how you get there. So fossil fuel use, and China is still building 75 coal-fired power plants every year. India is still very much relying on coal, fossil fuels from oil, gas. We really do need to find ways to decarbonize our societies. And so it's going to continue to be a problem in certain countries, and I think it will affect the world's geopolitics. Why do I say that, and what do I have in mind? One of the arguments that's used, not inappropriately, is that the Western world, the part of the world that I come from, America, Europe, made use of fossil fuels for the last several hundred years to build up industry and manufacturing. And we have been the major polluters of the world, the major cause of air pollution writ large, not the localized issues that come from one or another different problem. So an argument that's given back to us is that countries like India or China or elsewhere, well, we're entitled to our turn to build up our manufacturing, and so we have to use fossil fuels. The problem that I see is, even though the West contributed to the problem, we didn't appreciate that it was really a hazard to people's health. Now we know that. And so 20, 30, 40 years from now, if we don't do something serious about changing the trajectory, countries that are still going to be suffering, which are probably going to be places in Africa, parts of South America that are very poor, they're going to look at the then greater powers of India, China, and elsewhere and say, you made that argument, but you knew what the consequences were. You knew that you were making it worse, and that's affecting us. When the Maldives are going to have to be liberated of its people, there's a thing that came out, and probably by the end of this century, cities like Miami, which are at sea level, are going to be under feet and feet of water. They're already having problems. Bangladesh, 30 to 40% of the arable land will be underwater and unfarmable. And so are you going to argue, that allowed other countries to become manufacturing powers? So I think it's going to have those kinds of impacts. In terms of what actually goes on in workplaces and how we approach issues, there's a long history of the development of problems and the development of knowledge. Unfortunately, what we've learned is that the technologies that become available, be it the cotton gin and making cotton materials, far preceded our understanding that you could get bisonosis, cotton dust lung disease, from handling raw cotton. Now we're dealing with issues like nanoparticles they're starting to show up in many products. We suspect, and we're starting to learn, that there are health effects, but the technology gets away from us before we study the potential health hazards. So we had the rise of manufacturing with the Industrial Revolution of the West starting in the mid-1700s. That brought people from rural areas into cities, into crowded situations. It made things like tuberculosis far worse because of living conditions. It took until the 1850s and until 1900 to have laws regarding women and children in the workplace. Unfortunately, in the United States, where we have protected children from certain kinds of work and hours of work, we have some individual states reversing that, letting children as young as 13 and 14 work with extremely hazardous equipment, power saws and things that they would never be allowed near previously. That, part of the problem is we don't always have enough workers, and the workers we have may be people in our country who are undocumented, who have come for a better life or fleeing conflict in their own countries, but governments wanting to make political points or saying, we're going to let children do the work so we don't have to use some of the work from these people. Worker safety started to be thought about 1900 and thereafter. There was some serious incidents early in the 1900s where it brought to the fore the idea that workers could be harmed at work. Silicosis was the big issue of the 1930s, asbestos the big issues of the 60s and 70s. With the advent of computers, we've now had huge numbers of people developing musculoskeletal problems from working full-time on computer keyboards. By 2000, we were worried about estrogenic chemicals and pesticides and their effects. And now in the 2020s, the big issue, at least that you start hearing about, are these so-called forever chemicals, the perfluorinated compounds, the PFASs that are out there, hundreds of them, as well as thousands of pesticide formulations. So we've never solved any one of these problems, but we start creating new ones. India is a country that has resisted safer materials. We're going to talk about asbestos. You still make use of some hazardous pesticides here that other countries have banned, which is unfortunate. But we contribute to that too from the West. There are materials that we no longer allowed to be used in the West. Sometimes we continue to make them, but don't use them and sell them to other people, or they just simply shift the manufacturing of these to other countries like to India. Another worldwide concern is the lack of appropriate numbers of people in safety and health. We don't have enough occupational physicians or nurses trained in this area, or industrial hygienists, or safety people, or radiation physicists. All of these people that look after health and safety at workplaces don't exist in enough numbers, including here in India. So that's the first overview. And think of the things in whatever areas you work in that are part of this major picture of change. But now I'm going to take you on a much more sort of intimate journey, and that is the world of asbestos, just as one example of the development of knowledge and how we do or do not respond to dealing with this very well. The word asbestos comes from a Greek word meaning unquenchable. The Greeks knew about asbestos. The Romans knew about it. They mined it. In fact, the Romans knew that it was a hazardous material. They had slaves mining their asbestos. And the lamps in the temples were made out of asbestos wicks. I mean, if you burn a candle with a cotton wick, the wick burns, the candle burns, it's gone. As long as you kept those oil lamps filled and you had an asbestos wick, the lights would stay on forever. And they wanted these lights never to go out, so they would use asbestos wicks. 4,000 years ago in Finland, where they had a variety of asbestos, they used it to make cement materials to fill in holes in homes. And asbestos is a term that really applies to 6 different naturally occurring minerals. By naturally occurring, nobody makes asbestos, it's out there in nature. It is mined, it's separated from its parent rock, and then in the past, put into as many as 3 to 4, maybe even 5,000 different products. We don't have enough time. I could go through a litany of some really odd materials or products that are out there that you would never dream would have something like asbestos in them. 98% of the asbestos used in India, and India is now the #1 utilizer of asbestos in any country in the world. 98% of it goes into cement sheets and cement water pipe, and 2% goes into brakes and clutches for automobiles. We'll get to that. Comes in 2 varieties. 5 of the 6 are called amphiboles. They're straight and needle-like in their presentation. There's one serpentine form, which is makes up 95% of all the asbestos ever used, and virtually the only fiber still used here in India or wherever it's still used. And that's the white asbestos called chrysotile. And we're going to talk about what the Indian asbestos industry and others have said about the white asbestos. So I'm going to show you this slide, and I have here it's not the easiest one to see, but there's an asbestos body. And this is a fiber of asbestos that, as it enters the lungs, gets coated with an iron and protein matrix. For every one of these asbestos bodies, sometimes called ferruginous bodies because of the iron, but most of them have as its core asbestos. For every one of these, there are hundreds, if not thousands, of smaller uncoated fibers that are in the lung. And I sort of hate to tell you, but everybody in this room has some asbestos in their lung. You're not all going to get asbestos disease. The levels that are there in the ambient environment are not likely to give disease, but it's probably not impossible, as you'll see. This piece of tissue that I'm showing you that this asbestos body comes from was from an autopsy done in the year 1899. A man of 36 told Dr. Montague Murray that I and 9 batchmates, 10 young men, started working 10 years earlier at an asbestos factory at the East End of London. And at the London hospital, he said to Dr. Montague Murray, "I'm the 10th and last to die, and we've all had lung problems, basically respiratory insufficiency." And he died, and he had a post-mortem done, and this is what was seen in his lung. Montague Murray didn't know what to make out of it, so he called it a curious body. And we finally figured out what it really was. But he was aware that this was a hazard. So right now, we still produce about 1.2 million tons of asbestos. Most of it comes from Russia, Kazakhstan, China still mines it. The mines here in India have been closed, but there's still some illegal mining that goes on. Brazil has banned and closed the mines, but there's a little loophole, so one mine is still open. So there's still over 1 million tons a year being produced. This is a somewhat older slide. India and China use together half the world's supply. China has cut back on its use. India, as I said, is now the #1 user of asbestos. But let's put this into perspective. The World Health Organization estimates there's some 250,000 asbestos-related deaths every year. The true number in India is unknown. There's lung cancers, there's mesotheliomas, there's asbestosis cases, there's other cancers we'll talk about. So it's a significant problem. 1.2 million, 125 million workers around the world still work with asbestos on a regular basis, and 250,000 die every year. About 70 countries have totally banned the use of asbestos. The United States, we're the only country that has a partial ban for some uses. It's a horrible situation. I've been working literally for decades to try to get my own country, the only mature, developed country that hasn't banned asbestos. We haven't caught up with Croatia, we haven't caught up with Malaysia, we haven't caught up with other countries that have completely banned asbestos. India, of course, has not banned asbestos. And when it comes up to things like the World Health Organization, the so-called Rotterdam Convention, where nobody's looking to ban it, they're simply saying, if you enter a material into the Rotterdam Convention, you have to warn people that it's a hazardous material. And not surprisingly, because all 160 countries have to unanimously vote to list material, who blocks it? The Russians, because they mine it. Kazakhstan, because they mine it. in India because you use it. And so work needs to be done to protect people around the world, including in this wonderful country. We ask the question, does stopping use stop the disease? And the answer is yes. I mean, as a concept, it makes sense that if you stop exposing people to carcinogenic agents, it's going to reduce disease, right? But when you stop and think about it from a public health perspective, I can only name very few things where we've actually shown that to work in practice. Tobacco use. Males have, at least in the United States, many males have given up cigarette smoking. The majority of cigarette smokers are now women. Women have more lung cancer from cigarettes than men. But as men have given it up, their rates of lung cancer have come down. Material called vinyl chloride. The gaseous material that when compressed makes vinyl plastic, that makes all the vinyl products that we're used to. That was causing angiosarcomas of the liver, very rare cancer, but definitely related to that. When we very much restricted the use of that, or the amount that workers could be exposed to, the disease essentially disappeared. So we know that stopping material use stops disease, and we know it for asbestos. Sweden stopped using it over 30 years ago. Their mesothelioma rate is coming down. It's not gone, and it won't be gone for a long time, but we'll explain that. But stopping use stops disease. We also know that data collection in many cases is poor. There's a simple public health adage: the absence of data doesn't mean the absence of disease. And the fact that countries don't have good records doesn't mean that there isn't disease. Diseases like mesothelioma are grossly underreported in many, many parts of the world. And I could go into all kinds of details, but we don't even appreciate the size of the problem. There are some legitimate areas of asbestos controversy. We still are learning about the relative toxicity of the different fiber types. Not that it matters. Every one of the 6 fiber types, the white asbestos, the brown asbestos, the blue asbestos, the other forms, they all cause all the diseases we're going to mention. Fiber size, we know, makes a difference. Fibers of a certain size are more likely than fibers of other sizes to cause disease. But again, people were saying, well, if it's less than 5 microns in length, it's not going to cause disease. That's clearly not true. The fellow who came out with that hypothesis, a fellow named Merle Stanton, he was a pathologist at the National Cancer Institute. I met him when I was there. We did a little work together. He shared with me some of his materials that were sized particles, and we showed that even fibers less than 5 microns. Now, what was this magic 5 micron thing? That was the limit of light microscopy. They couldn't find fibers less than that, so they said, we don't see them, so it must not be causing disease. Obviously not true. Fiber synergy. There's some epidemiological studies that if you mix the 2 fiber types together and expose people, they seem to have a synergy. So there are legitimate questions. But on the other hand, there are contrived controversies. The so-called safety of chrysotile. The asbestos industry here in India says the white asbestos is the safe asbestos. It doesn't cause disease. And they cite literature, paid for by the Russians, paid for by the asbestos companies in the United States, paid for by the asbestos companies in Canada, that any reasonable scientist, when you look at the weight of the evidence, for all of those people that did studies that were not paid and bought for by industry, showed otherwise. I'll show you data. Biopersistence is an issue that they raised. They said, chrysotile disappears out of the lung in 90 days. It can't be causing disease, it goes away. The amphiboles, they stay for 2 to 3 years by way of half-life. They're the ones that are causing disease. And so they say, it's the amphiboles and the chrysotile is safe. What they don't tell you about this issue of biopersistence, I absolutely agree. Chrysotile leaves the lung. But what they don't tell you, where it goes. There are 3 countries now, with scientists in each of those countries, that have shown that the cases of mesothelioma, which affect the pleura, not the lung tissue itself, not the parenchyma, that the pleura in 80% of cases only has chrysotile. Yes, it leaves the lung and it moves to the pleura, And so if you don't find it in the lung, you can't say it doesn't cause disease, because if you look in the pleura where disease, mesothelioma actually occurs, you're going to find chrysotile, not the amphiboles. I mean, amphiboles can do it too, but that's an argument that doesn't hold. They talk about so-called controlled use. No country has ever controlled the use of asbestos. Even Canada, which has some of the strictest rules, did a little study. They went to 10 workplaces where there was supposed to be controlled use. One out of 10 workplaces actually had good control of the fiber. 9 did not, and this was a country with good regulations and good inspections. And then the most ludicrous argument, and I've heard that from the industry here, Indians don't get mesotheliomas because the genetics of Indians are different than Westerners. I'm sorry, we share 99.999% of our genes. Your genes are no different than my genes, and guess what? Indians get mesotheliomas to a 10-year period in a small number of hospitals. When you ask them for their data, in a 10-year period, he was able to locate over 2,200 cases of mesothelioma. They occur here in India, grossly underreported, and genetics has nothing to do with this. Getting back to Dr. Montague Murray, 1906, when he did the autopsy 7 years earlier, he wrote, "When here's generally speaking that considerable trouble is now taken to prevent the inhalation of dust, and so the disease is not so likely to occur as heretofore." 1906. By 1918, an insurance company in America stopped writing life insurance policies for asbestos workers because they knew they had a shorter lifespan. And as we sit here today in 2024, we have this spectrum of asbestos disease. We have non-malignant disease, asbestos warts, benign asbestotic pleural effusions, asbestosis, both of the parenchyma and the pleura. More importantly, we have a whole range of malignancies: lung cancer, mesothelioma, pleuroperitoneal, pericardial, even testicular in males. We have esophageal, stomach, and colorectal cancers in excess. That's been known for 50 years, but doesn't get much thought. Laryngeal cancer, oropharyngeal cancers. There's a study out of Canada, Canadian chrysotile miners have excess tongue cancers, and they find asbestos fibers embedded in the tongue. Not common, but seen. Renal cancers are found in excess, and in women, ovarian cancer. So a disease that we knew over 100 years ago could, a product that could cause disease, we've let hang around and cause more and more disease for the last 100 years. We can identify fibers. You do microscopy. You can do light microscopy with refractive indices to identify fibers. You can do scanning microscopy, scanning electron microscopy. This is a chrysotile fiber with individual fibrils. Now you know why they call it the serpentine form. It's wavy like a worm or a snake might be. And then under TEM, we show that these individual fibers of chrysotile are a rolled sheet silicate. So you have to know, and you learn some things about geology and mineralogy. It's a material rolled up on itself, sort of like a soda straw with a hollow core to it. You can even use electron diffraction and identify individual fibers by their signature. Is it iron containing like amosite, or is it low in iron like chrysotile might be? And here's a much better looking asbestos body. Again, I would venture that everybody in this room probably has some of them inside of you. This is a better and clearer picture. This is the fibrotic changes you see if you remember your anatomy of the physicians. Lungs should be nice and thin and lacy so the oxygen can transfer out of the bloodstream or into the bloodstream from the lung and get rid of the CO2. But here you get this thickened tissue, which is why asbestotics and anybody with dust disease who gets fibrosis ends up with a hard time breathing. Radiology, of course, can tell us what they look like. I'm not going to dwell on that. This is a Canadian chrysotile miner, 43 years of age. That thick white rind around his lung is clearly not, thank you, a mesothelioma in this case. That's a thickened pleura. This is from a chrysotile miner. So please don't tell me it's the safe material. The only reason we ended up having the specimen, he had come to Mount Sinai many years ago for a decortication on one side. while he was recuperating from that, unfortunately, as many of you know, the worst place to be if you're sick is to be in the hospital, because you get more disease being in a hospital. Obviously, you need to take care of people, but it's not great places to be. And he developed a pneumonia and died, which is how we managed to get an autopsy on a young man. All right. The first epidemiology about lung cancer was 1955. It was more than 10 years earlier that they suggested that asbestos, well, it was 1935, the suggestion was made that asbestos could cause lung cancer. And by 1942, it was written about in textbooks that asbestos caused lung cancer. And the epidemiology finally caught up with it in Great Britain. They expected 4% of deaths in the workforce from lung cancer, they had 17%. The lung cancers are the same lung cancers you get from smoking or other things. The cell type distribution is pretty much the same. What is a little different is the location. Asbestos fibers tend to settle in the lower parts of the lung, different from silica, which tends to first go to the upper parts of the lung for reasons we don't particularly well understand. And so many lung cancers are moved from where they usually occur in the upper and central areas down to the lower lobes and peripherally. And so sometimes you have trouble sorting out, is it a mesothelioma or is it a lung cancer? But this is a typical peripheral lung cancer. This is a tobacco field. I taught for 11 years at the University of Kentucky, one of the biggest tobacco growing states. Why am I showing you tobacco? It's a cause of lung cancer, of course, but there's a tie-in with asbestos. If you don't work with asbestos and you don't smoke, you have a risk of getting lung cancer. In fact, we know now, just literally this year, we've published a series of 7 papers with colleagues from Australia and Turkey and the United States. If you read the journal Lung Cancer, there's a series of 7 papers put together on asbestos and lung cancer. We know there's more and more non-smoking lung cancers. But there always has been some such cases. And so the basic rate, this was back around 1980, 11 cases per 100,000. So we'll take that as the baseline, ratio of 1. If you work with asbestos but don't smoke, asbestos alone will increase your risk of lung cancer 5 times. If you smoke, the average 1-pack-a-day cigarette smoker, and don't work with asbestos, you have a 10 or 11-fold increase of risk of getting lung cancer. But you put the two together, the smoking asbestos worker had a 50-fold increased risk of getting cancer. There clearly was this synergistic effect that can be seen here. And so that's why I showed you the tobacco, because there's a reason. And as a clinician, when I see an asbestos worker, the first thing I find out, not the first thing, but early on, are you a smoker? And let's talk about giving up smoking for just this kind of data. Typical appearance of a mesothelioma. Most of them are in the pleura, there's some in the peritoneum, but about 90% are pleural. They present with shortness of breath. You take a chest x-ray, you find an effusion. You can also get calcified plaques, you get diaphragmatic plaques. These are all caused by exposure to asbestos. This is what a mesothelioma might look like at a post-mortem. It just encases the lung. It's a horrible death. I mean, it ranks up there with pancreatic cancer and some of the other really poor cancers. Here's an asbestos worker. He had 3 episodes of benign asbestotic pleural effusions. Scared the heck out of us each time. It's a bloody effusion. You're sure there's a cancer in there. You can't find it. It clears up. He ended up with a peritoneal mesothelioma. So let's look at something about these fibers. Okay, these are all the different asbestos, or many, not all of the fiber types. And look at that data, here in the middle. Okay, if you look at lung cancers, you got as many from chrysotile as you did from the amphiboles. If you look here at the mesotheliomas, some people say, oh, it's the blue stuff, the chrysotolite, that's the really bad one. Well, it really isn't if you look at this data. And in fact, there was just a new paper about 3 months ago that showed that you get actually more inflammatory response with chrysotile. A lot of people think it's the inflammation that ends up leading to the malignancies. So there's plenty of data, and if you look, even the Russians who claimed, our stuff isn't bad, they just had a paper come out jointly with IARC showing, Russian chrysotile miners get excess lung cancers too. So don't believe that chrysotile is the safe asbestos. The other question you might ask me, well, doc, how much asbestos does it take to give you disease? How much exposure do you need? Well, the same Dr. Wagner, in his studies, showed that if you put rats in an inhalation chamber, as little as 1 day of exposure gave them both lung cancers and mesotheliomas. And it's not perfect, but there's sort of a dose-response curve. The more exposure, the more disease. And I will tell you, in my career, not all of these have been written up. There's some that are in the peer-reviewed literature, but not all of them. I personally know of 5 cases where it was documented that people had 1 day of exposure. 2 sisters, genetics certainly seems to play a role. During World War II, they were both university students. It was summer break. It was the war. They decided to go work in a shipyard. They went to work. They found it so dusty and dirty, they said, never again, and they never went back for another day. And 30 years later, the 2 sisters each developed a mesothelioma. There's other reported cases, again, some in the literature. As little as 1 day of, I will admit, probably heavy exposure has been sufficient to give both humans and animals mesotheliomas. For lung cancer, this is some work from an asbestos factory that we studied at Mount Sinai. I started there as a student. I spent 15 years there, leaving as an associate professor to go off and start a professorship and a department head at another university. But look at this data. A month or less of working there doubles your risk of lung cancer. A month or less. And by the time you worked there for 2 years, you had a 7-fold increased risk of getting lung cancer. It doesn't take much. It's a very powerful carcinogen. Compare that to cigarette smoke, where not only do you have to keep smoking for decades and decades, but if you give it up, the tissue can reverse itself and get healthier again. You can stop asbestos exposure, but guess what? The fibers stay in your lung for the rest of your life. And you can, if you're a cigarette smoking asbestos worker, you give up the cigarettes, your risk really does come down, but it comes down to the baseline of just asbestos exposure. The other question is, when do you get disease? What's the latency? I've talked about the duration of exposure. This is the latency period, the duration from onset of exposure. You start to see cases 10 years, 15 years, but look at the peak. It's out at 45, 50 years now. We're seeing in lower levels of exposure even longer years, but 35, 40, 45 years. So you get a patient who you even find a mesothelioma. You know, the exposure may have taken place 40 or 50 years earlier. I've seen 90-year-olds who worked with asbestos when they were teenagers. First of all, you ask them, were you ever exposed? They may not have known that it was asbestos. And even if they knew, they might not remember. So it's important to get histories and be able to link these things together. The carcinogenic mechanism is still unclear. I spent part of my work with cell cultures and organ cultures. I've done whole animal work. I still can't tell you exactly how asbestos causes cancer. We know it alters DNA, but mechanism still not quite clear. So where do you get exposure to asbestos? There are any number of significant risk occupations: asbestos mining and milling, manufacturing of products, putting it into insulation and construction products, shipbuilding and ship repair, people who work on ships, naval personnel, power production, railroad work, but also we'll talk about household contact, consumer products, neighborhood contamination, waste disposal, transportation issues. All are risk factors for asbestos disease. Spray material. First introduced in 1932 in Great Britain, a product called Limpet. It was a spray-on material. It was first used in the United States in 1935. And by 1970, more than half of all large multi-story buildings were being fireproofed with asbestos spray-on material. That was for fireproofing. They also were making products for noise control. So they would mix asbestos in with some fairly bland material and spray it, and it would end up in schools, walls, ceilings, full of noise control material, full of asbestos. I've actually seen a case fairly recently of a young man who went to school in such a building. the students would carve their initials in the ceiling, and the dust would come down. He ended up 40 years later with a mesothelioma. It doesn't take much material. Okay. You may recognize this building. It's one of a pair of buildings. That's the World Trade Center. That's the first tower. The ban on the spray of asbestos came into being while they were building the first tower. So the first 40 or so floors was sprayed with asbestos. After that, they used a non-asbestos material. The second tower had non-asbestos material. And here's an asbestos insulator literally spraying asbestos on a steel beam at the World Trade Center. And as you see, some of it even stayed on the beam. What happened to the rest of it? This is what the laborer had to come by and sweep up. This is what the electrician was exposed to. This was what the brick mason was exposed to. And so everybody in a construction site in those days was being exposed, even if in their trade they never handled asbestos. That's why every construction worker of certain periods, they were all at risk. It didn't matter if you worked with asbestos or not. This is the hold of a ship. All of this material, these blocks here, the coverings over the metal here, this is all asbestos. Not surprising that shipyard workers, naval personnel would get asbestos-related disease. Peter Harries did a study in England at the Devonport dockyard. The cases of disabling asbestosis, not just ordinary everyday asbestosis, the ones where the workers were disabled. A third of them were the so-called sprayers and laggers who actually decided, let's figure out what's going on. And in a 28-year-old, or maybe by now 29-year-old, he developed a diffuse malignant pleural mesothelioma. And so they did a lung biopsy. They had both chrysotile and amosite in his lungs. And he died just before his 30th birthday of his mesothelioma. So the logical question is, 30 years old, he'd been an accountant at university, he'd worked as a bookkeeper, he'd never worked with asbestos. How could a 30-year-old or almost 30-year-old be dying, proper latency period, of an asbestos-related disease? Well, maybe it wasn't asbestos. Till you got a map out of Brooklyn, New York, one of our boroughs, okay? And there's two white dots here. This is Ross Street and William Street. That's where he was born and lived, right next to the Brooklyn Naval Shipyard. What did we say before? The product doesn't stop at the factory gate. It blows out into the neighborhood. He had an exposure starting at birth, living in this neighborhood. And I will tell you, on this street here, there were little shops and things, machine shops and things that worked in support of the Navy Yard. We've seen a case of mesothelioma from there as well. So one shipyard, two environmental cases. This is a town about 30 minutes away from my university office. It's called Ambler, Pennsylvania. It was called the asbestos capital of the world. They had more asbestos factories there than a lot of other places. And there was a 30-meter high pile of asbestos waste ringing large parts of the community. They would just throw the waste out and pile it up. So the local kids would play on it. Not surprisingly, Ambler, Pennsylvania has one of the highest rates of mesothelioma of any community in the United States. Fortunately, now they've covered it with grass and dirt and whatever, but for many years, this is what it looked like. Remember the London hospital, Dr. Montague Murray? Well, the same hospital, Molly Newhouse, looked at mesothelioma cases between 1910 and 1965. Not surprisingly, about half the cases were workers who worked at that same asbestos factory. But 9 were among relatives, people who lived with those workers. So it was actually 5 years earlier that in South Africa they said that asbestos cases, mesotheliomas, could be in family members, but she had a larger number. 11 of them lived within half a mile of the plant, so general environmental pollution. Now, where it says no known exposure, that's really because they had old hospital records. I assure you, in 1910, nobody was asking, did you work with asbestos? So it just makes the point that you can have household and general environmental exposure. In Finland, before they closed their mine, they looked at County A, where they had an asbestos mine. almost 500 calcifications on x-rays of 6,300 people. County B, no mine, 0 calcifications on a chest x-ray, 7,100 people. General environmental exposure. I told you there were many, many products. This was an old can of leak-proof asbestos liquid roof coating that somebody gave me because they knew I was interested in this. I've donated it to a fellow who has sort of a museum of old asbestos products. There were thousands of products. You can even see the smokestacks are billowing pollutants coming out. You'd never see a picture like that somebody would want to use to sell their product anymore. It used to end up in the schools. They would take the waste material and make papier-mâché materials for school children. Go to school and make the asbestos head. It was used as Christmas decoration. Throw it around your tree so you have a safe and fireproof Christmas. And then there's this one. One tobacco company actually used asbestos filters in the 1950s for a few years. Think of that. You could get a puff of your carcinogen with every puff of your carcinogen. And the people who made those filters and the people who smoked those cigarettes ended up with mesotheliomas. There are doctors here. We've all written prescriptions. I've written prescriptions for my patients. Until the FDA, the Food and Drug Administration, banned the use of asbestos filters in America, I would be injecting asbestos into my patients. Why? Because they used asbestos filters. So it didn't matter if it was your antibiotic or your Valium or whatever, the bottom of that vial were these asbestos particles. And you'd mix it up and inject it IV, IM, whatever, and you were putting asbestos into people from the drugs we were using to cure them. So, we're in a one world marketplace now, Globot. We have to produce to the same high standard around the world. What about health and safety standards? That depends which part of the world you work in. So, I've spent time in China. Here's a couple of ladies making asbestos brakes for cars. Those aren't respirators, those are cotton gauze masks. It's not going to keep the fibers out. This was the textile part of the plant. That's asbestos on the floor. Again, the ladies are not being protected. This is the whole story in this one little vignette. The picture's not great, but I'll tell you the story. The gentleman in the background, the white coat, he was the plant doctor. This is China. This was 1993 when I took this picture. He had graduated from medical school in the southern part of China. The government said, we're going to send you to a part of the country you have no familiarity with. You're going to become the plant doctor at a plant in a northern city bordering on Russia, and that's where you're going to work, and that's his job for the rest of his life. So he worked at the asbestos factory. He was a curious gentleman, and so he took care of his workers. He did well by them, but he also kept his own private notebook. And because I could look at his notebook, I couldn't read the Chinese, but they would translate for me. He had his cases of lung cancer. He had his cases of mesothelioma, having worked for 30 years at this asbestos plant, making textiles and making brakes. Now the lady and the gentleman here, he was the dean of the School of Public Health in Beijing. He was sort of my translator on this trip. And I've worked with that entity in some other places in China. This lady, I had first been there 2 years earlier, and they had a 6-day work week, but in 1993 they had gone to a 5-day work week. So this was a Saturday, and she wanted to work a little overtime at the asbestos textile factory. You can't really see, but these are textile looms here. Okay, what was she going to do with her daughter? She had no place to put her daughter, not in school, not in daycare. So it's bring your daughter to work day at the asbestos factory. I cautioned them that it was not a great idea to bring little kids into environments that were loaded with carcinogenic material. So even just this one little vignette has so much to tell us about what to do and what not to do. Here's some pictures from India. Is this controlled use? Do you see a dust-free environment? Do you see these pipes without dust on them? This is what people making it, putting it in the ground get exposed to, repairing it. Not to mention the asbestos that leaches out into the water that people are drinking, giving them, I suspect, colorectal cancers and esophageal cancers and kidney cancers. And then we have the problem of Alang, with the ship breaking. A ship, a small naval vessel will have 40 tons of asbestos. Something the size of an aircraft carrier could have 100 tons of asbestos. And that has to come out as they take apart these ships. And here's what the pipes might look like. They literally rip the asbestos off, put it down on the beach, let it dry, and then somebody resells it for somebody else's use. Talcum powder. I venture to say hundreds of millions of Indians, many of you likely, use talcum powder on a regular basis. If you know anything about the chemistry of talc, it's very close to the chemistry of asbestos. And most talc deposits are contaminated with asbestos. And on one of my trips here, I took some samples back to America, and we acquired some more, and we looked at 13 Indian talc samples. 7 of the 13 were heavily loaded with asbestos. I'll even tell you a personal story. When my youngest child was born, you get a little basket when you take your kid home from the hospital with a few diapers, and maybe some cream, and I got a little bottle of Johnson & Johnson baby powder. Little bottle. For some reason, my wife, I did my share of diapering, she did the bulk of it, but we never used baby powder on them. I don't know why. I think she used cornstarch. That was her thing to do. And we dragged that bottle for 35 years from house to house. And finally one day, because I'd had this experience with Indian talc, I said, and I testify in court, I need to come clean. I've been testifying for injured people for 45 years, mostly related to asbestos. The monies have all gone to my universities. I've never kept any of the money till now. That's what allowed me to travel so many times to India and China and whatever. I use those monies for my research. And I testify against Johnson & Johnson. And they said to me, after I'd sent this bottle off for testing, they said, do you have any new data at a deposition? Any new data about our asbestos or our baby powder? I said, yes, I do. The only reason you last for 45 years in court and testifying is you don't lie. You always tell the truth, because they catch you in a lie, you're no good as a witness anymore. I said, yes, I have some new data. Oh, what's the new data? Well, here's this bottle I've had for 35 years when my youngest was born. Never opened, still had the original sealing cap on it, so you can't argue that it was contaminated, as I dragged it from house to house. So never opened, and it had 58 million structures of asbestos per gram of fiber. They went, can you send us a copy? 3 or 4 years ago, I sent them a copy of the report. They still go to court today and look juries in the eye and say, our stuff doesn't have asbestos in it. I beg to differ. Anyway. So this is how talc gets sold here in India. The kids like to blow on it, and that's our publication, American Journal of Industrial Medicine, Asbestos and Commercial Indian Talc. If you don't believe me, there's the fibers that we actually found. We found children's makeup, not here, but stuff that you can buy in Europe. 234 million asbestos structures per gram was reported on TV in New York. Or in the United States on TV. So we find it in many products that you wouldn't think about. Children's toys, a product came in from China. Be your own detective, do your own fingerprints. Here's the dust that you can sprinkle. It was loaded with asbestos. So I just told you the story. That's my bottle of Johnson & Johnson baby powder in the laboratory. Those are my initials on the bag that I sent to my lab to be tested. Okay, why do I spend time with legal issues? Because in the world of public health, legal issues can bring about change. Johnson & Johnson, not just because of me, but because of lawsuits, has stopped selling talcum powder. First, they were only going to stop selling it in the United States. I wrote a letter to the editor, to my local newspaper in Philadelphia, saying, isn't this wonderful? They're going to stop selling asbestos in the United States and protect Americans, but they're still going to sell it in 160 countries around the world. Finally, they stopped doing that. And we don't even know what the problem is here in India because the data is not good. We need things like a mesothelioma registry. We need a broader cancer registry that covers the whole country. These are things that are practical, that will help understand the nature of these issues. So I showed you the World Trade Center going up. This is the World Trade Center coming down. Those beams, many of them had asbestos on it. What happened to all that steel from those two buildings? They got recycled. They were sent to India. They were sent to China. But we weren't very good citizens of the world because we sent them over with the asbestos still on it. We didn't take it off and bury it in America. We sent it and let Indian workers take the asbestos off. The dust in Lower Manhattan had up to 4% asbestos. People's apartments were loaded with dust. Workers were sent in there with a cloth rag and a spray bottle of water to clean this up. And some of us predicted in 2011 that 20 years later we'd start seeing mesotheliomas. And guess what? Unfortunately, we were right, because we're starting to see the mesotheliomas of people that were exposed because of the World Trade Center. So this is what I mean about, people were, so hard to try to save people that were unsavable, and you see all the material that was still sent over that was on the beams. So the legacies of the past is, if we stopped using asbestos today, stopped it and no more exposure ever again, we'd still have disease 50, 60, 70 years from now because of the long latency. Industrial use, as I've told you, is still continuing. Engineering controls are not well developed. In America for years, even now, we tinker with regulatory feasibility instead of an outright ban. Uncharted legal complexities. I've testified in America, in Canada. I've done some cases of exposure here in India. I've done some cases in Australia. I do this to try to give some due to people that have been injured. And in America, for example, we have at least 25 million tons in place in buildings from past use. Most countries don't even know how much they've got in place. And so the final lesson is asbestos disease, one of the pneumoconioses, all of them, silica dust, coal dust, mica dust, kaolin dust, are all best treated by prevention. If you stop using it, people will stop getting sick. It'll take a while, but that's what we need. So thank you so much for your attention.
Thank you so much, Dr. Frank, for a very illuminating talk. Anybody has any questions? I think we really need to be cautious, not only environmental health, but our health also. Dr. Salman.
I must first compliment your tremendous work, particularly. It's very difficult, as you said. It's legally challenging, I will say, to work on this. And these are the things we hardly talk about, As you started, in our medical field, we usually say that we skip environmental history in our history taking in the medical school. So this is our start. So it's very good to sensitize the younger people who are here, so that they can take up few research in this particular cause, particularly in this part of the world, This is what is required. Thank you for enlightening us.